The insane pressure at the bottom of the ocean will destroy just about anything. So why has the Titanic remained remarkably intact down there for over a century? The tragic destruction of the OceanGate's Titan exploration vessel in 2023 left folks with a lot of questions. Mainly, what exactly happened when the submersible lost contact with its support ship 1 hour and 45 minutes into its descent? Was there a structural defect in the Titan that led to its implosion? Was it human error?
I feel that this was such a preventable tragedy.
Not every vessel that sinks in the water implodes, though. The Titanic might be a decrepit, crumbling mass at this point, but it still has its original boat shape. And it's been sitting nearly 13,000 feet under the surface of the ocean since 1912. But the deeper underwater you go, the stronger the pressure gets. As Scientific American says, pressure increases at a rate of 15 pounds per square inch every 10 meters below the surface. That means for the first 10 meters down, the water pressure feels about the same as the air pressure when you're walking around on the beach. Below that, things start to feel really compressed really quickly. So what if a vessel is designed to be a perfectly airtight, self-contained bubble like a submarine, but still has some defect? It'll get instantly crushed from the outside. The Titanic, on the other hand, isn't a sealed vessel like the Titan was, and thus hasn't been affected by pressure in the same way. Water pressure is no joke. As Scientific American explains, the pressure felt when underwater comes from the water above you. And that's why things feel more compressed the deeper you go into the ocean. The entire mass of the ocean is sitting above your head. And down at the Titanic's depth, well, the pressure per square inch equals around 6,000. So no, you wouldn't survive for one fraction of a second down there unless protected in an airtight submersible shell. And yes, a submersible would crumple in an instant if it had the slightest defect or crack somewhere. Death would be instant. In fact, the pressure is so severe in the deepest depths of the ocean that folks have to rise slowly to avoid getting decompression sickness, also known as the bends. Harvard Medical School says that decompression sickness symptoms include joint pain, dizziness, numbness, and difficulty thinking. And when descending into the deep, the pressure inside a submersible needs to stay equal to the pressure on its surface. It needs to push out as much as the water pushes in.
You feel somewhat like you're on a totally different planet as you descend.
To better understand why the Titanic didn't crumple like a paper ball when it sank to the bottom of the ocean, we can look at a simple comparison. The Washington Post says that a car door has up to 600 pounds per square inch of pressure pushing on it from the outside if a car dives into the water. So if you fly off a pier, you'd have to be pretty strong in order to get the door of your car open. But that's only because of the difference in pressure between the inside and outside of the car. Open a window, and the pressure differential vanishes because water floods inside. The Titanic, on the other hand, sits at a depth subjected to 6,000 pounds per square inch. That's 10 times more than your hypothetical car door. Flat slabs of steel won't get squished down there like slices of bread. Neither will the railings in the deck or any objects inside. By the time the Titanic hit bottom, any pressure differentials across its hull or throughout its interior sections had long balanced out. Much of the current decay and decomposition we see across the Titanic comes not from water pressure, but from the exchange of oxygen molecules between metal and water. So for now, it seems the wreckage of the Titanic is safe, if anyone is willing to risk the journey.